Welcome to the Control Engineering webcast. Advanced Analytics from Plant Floor to Cloud, it's not a one-size-fits-all. Sponsored by GE Digital. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh the browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or by adjusting the volume on the volume of the webcast platform. If you're having technical problems with the audio or the slide presentation, click on the question mark at the top right corner of the screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Type questions for our speaker in the Ask a Question box at the left side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of the screen. Those documents will also be available with the on-demand version of the webcast. I'm happy to introduce today's distinguished speaker, Naran Gopalkrishna. Naran has more than 25 years of experience working in the software space. In his current product management role at GE Digital, he manages two products, Manufacturing Data Cloud and Prophecy Operations Analytics. He holds a bachelor's degree in software engineering and a master's degree in management of technology from EPFL. Thank you for joining us today, Naran. Please go ahead.
Hi, this is Naren Gopalkrishna. Good morning, good afternoon, good evening, wherever you are. Thanks again to Mark for the nice introduction. My first slide is to introduce you to GE Digital, and manufacturing software within GE Digital. As you know, GE has four main businesses: GE Power, Renewable Energy, Aviation, and Healthcare. GE Digital, as you can see, covers a spectrum of software that we implement within our business as well as at our most valuable customers. In GE Digital, we have four main divisions: grid software. 40% of the electricity generated on the planet is touched by our software. Manufacturing software, this is where I belong to. We have more than about 30 years of experience and over 18,000 active customers using our software in some of the major industry verticals like CPG, F&B, automotive, pharma, water utilities, etc. The other divisions are PGOG, which stands for Power Generation, Oil and Gas, where we manage more than about 2,000 gas and steam turbines, roughly about 1/6 of the world's install base. Aviation software, which helps 450 plus customers to improve operational efficiency in the industry, ensure customer safety, and enhance passenger experience. Before we jump into the discussion, let me introduce you to what we hear from our customers when we talk about AI-enabled digital transformations. At GE Digital, the central theme of any product development or feature creation and innovation starts from the voice of customers. I'd be sharing with you a list of what we heard from our customers on some of the painful challenges that they face when organizing and using manufacturing data for analytics. At the top of the list is what can be called as one enterprise view of data. Organizations by nature are organic, meaning there is a continuous need to change, evolve, improvise, and make things more efficient. So if you look at large enterprises with multiple businesses, you will often see that manufacturing software configurations to be very different, not just across the enterprise, but also within a site or an area or a line. Changes could be in configurations, naming, comments, the way the process is followed, languages. There could be many challenges there, in terms of making it homogeneous. The other top challenge would be to have a homogeneous view of the KPIs or the data that gets extracted from this raw data, or it could be in terms of defining the business metrics. The next in the list was the ability or the option to actually learn across the site, cross-learn across the organization. Exceptions cannot be ignored in manufacturing organizations. So when you have data that's an exception and you have limited patterns to learn from, you have to look at similar patterns across the organization. Next is the ability, or I would say the lack of it, to separate reporting, analytics, and analysis workloads from operational workloads. This is important because for an on-premise application server, operational workloads needs to be prioritized. The rest of the workloads, such as analytics, analysis, and reporting needs, typically our customers want it to be moved to cloud. This isolation would not just improve the performance of on-premise applications, but also significantly speed up reporting and analytics by leveraging elastic and scalable compute and storage power on cloud. At the same time, you have improvement in the on-premise operations because of the reduced database size. There will also be a tangible reduction in the total cost of ownership, both in terms of hardware and the software support costs. Analytics is driven by data, but enterprises are looking for outcomes. They need to see results to continue to invest and stay motivated. There are various studies conducted on the role of analytics in general and manufacturing analytics in particular. I'd like to kind of take reference to one of the surveys on manufacturing enterprise journey to both data and analytics, organizing data and analytics. I'd like to quote here Gartner's Hype Cycle of AI, which was probably published a couple of years back, probably in 2019. It's worth talking about this because, before looking into the suggestions from some of our customers, who are heading the innovation or the Kaizen teams to drive these efficiencies, I think it's important to note what happens when organizations embark the journey. As per the report, the organizations that embark the innovation journey starts using innovation triggers like cloud data organization, cloud computing, augmented reality, AI, ML, deep learning, and various other technologies. And suddenly you find that the organization's expectations from AI, ML reaches its peak. But over a period of time, it starts dropping down into what Gartner calls it as a trough of disillusionment. This is what they capture in what they call as the hype curve of AI. As technologies gets incubated in organizations tend to see small little successes, but would be disappointed to see that the reality of the results and outcomes, and also the economics, falls way short of the set expectations and the hype that was created while probably incubating the AI-enabled digital transformation initiatives. The role of software platform vendors such as ourselves is to ensure that the customers reap the benefits of modern technology and start seeing greater value without falling deep into the so-called valley of disillusionment. They should try and see if organizations can reach the plateau of productivity quicker and faster. For this, some of the foundational elements needs to be addressed by employing the correct modern tools. These were some of the concerns expressed by people directly involved in some of the toughest challenges that organizations face and in solving them and driving continuous improvement programs. It's obvious that analytics is driven by data, and applying this to solve all kinds of problems is what essentially organizations are looking for. So the point is, as engineers, We do not want them to be spending time on correcting, combining, curating, cleaning, and contextualizing the data across the manufacturing value chain. Also, we would not them to be spending time on learning new domains such as data science or learning various software languages, or constantly depend on teams delivering this for every small little changes they make or every improvements that they plan to perform. What we would want them to do is rather apply their expertise and spend more time on establishing the right metrics, building business cases, and economically evaluating them. And most of all, use their expertise in equipment that they handle, in the process that they create, and in the operations to innovate. Choosing the right software framework, hence becomes very important. Not just any software framework, but a manufacturing software framework that's built on modern data architecture, following acceptable manufacturing practices, taxonomies, standards, and experience. This platform should magnify an SME or process engineer's expertise and should not expect him to be a software engineer or a data scientist. At the same time, one can't expect the data scientist or a data engineer to fully understand the domain, the challenges in the domain, and get the experience and expertise of the subject matter expert or a process engineer to efficiently build analytic solutions. When the process engineers, domain experts, SMEs, plant managers, and supervisors who are at the center of the problem-solving initiatives in manufacturing organizations would also be at the center of the analytics problem they solve, they start understanding what the data reads, focus on visualizing the data, and start using the information derived for their problem solving. What we have seen is a significant number of problems can be solved by a well-crafted visualization of data and by using simple statistical methods for data evaluation. Most organizations would have developed their own very specific KPIs to measure, track, and improvise. So it would be very important to actually kind of constantly evolve them, work with the domain experts rather than they spending more time on data science or organizing data. These engineers should be able to leverage the analytics platform, apply analytics models and algorithms to identify all the exceptions and the opportunities for improvement. This again has to be very relevant to manufacturing use cases because this has to provide them a low code or a no code option so that they can see results of analytics, start working on continuous improvement and quantify the efficiencies. Once the algorithm is tested on an identified area, we would actually recommend our customers to actually start with something smaller and manageable with a defined scope, probably with an identified area, process, or a set of operations. It should be possible for them to deploy, and test it out in a pilot production, and then turn to scaling up horizontally across the enterprise, across similar process, or across common asset models with minimum efforts. Now, what does manufacturing big data look like, and how is it different from general big data? While all the 4 V's of big data might not be applicable for manufacturing data from day one of the big data analytics journey in organizations, the variability that exists when it comes to accessing the data and contextualizing it with other data is possibly one of the biggest hurdles. We've used the term sensors here. You see here, that's at the bottom of the pyramid that you see in the hierarchy. This is used here to convey the basic element of the data that gets captured. These are not just control tags from equipment's processes or operations, but this also represents complex data like production orders, batch information, inventory levels, downtime records, or summarized information from more sophisticated systems, but would be related to the asset, the operations, or the process that we'll be studying. So what we might be typically looking for here would be the ability to connect to modern as well as legacy data sources, both on cloud as well as on-premise. It could be applications, or it could be equipments, or it could be systems. Aggregating data from both OT as well as IT platforms. Data integrity and what we would call as the contextualization of the data is something that's more important. By contextualization, we mean, setting the context for an event. Say, for example, if the event occurred, if, say, for example, a production event occurred, all the associated events along with that, probably waste was created parallelly, probably a number of downtimes had occurred during the production of that product, or many things would have happened, which at the time of production. So that needs to be captured, that needs to be contextualized. Or probably who were the crew, what were their training backgrounds, whether they were trained sufficiently, or all those kinds of information would be captured. Data required for analytics, would be kind of a little different from the high resolution data that gets captured at the equipment level, because that is captured in an isolated context. So this needs to be prepared when it comes to cloud. We need to have an optimized data retention strategy, meaning, when you're actually seeking for data from these equipments or from these systems, you should be able to get the incremental updates that happened before, from the time you actually queried last, relearn those patterns and apply new algorithms as we actually continue our journey. This needs to be, a constant or a sustained improvement program. It can't be, one-time activity. It needs to be sustained. So if we talk about Industry 4.0, it talks about the need for a connected asset process or operations to build AI-enabled connected applications, where the feedback is sent back to the process or to the asset or to the operation. This will be possible if all the stakeholders in the analytics process contribute to the development of analytics and quickly create value-added solutions. Technically, if you look at an asset, by asset I also mean a process or an operation, is different from a resource. Asset is maintained while a resource is nurtured. Resources grow, adapt based on the information that it gets, it picks up around. And this needs to, kind of learn and continuously evolve. An asset or a process or an operation turns into what is called as a strategic resource when it gets connected with the rest of the systems and the assets, and it's AI enabled. So this is the heart of Industry 4.0. So coming to the topic of today's discussion, a group of assets or a product or a set of products or a set of processes or operations could turn into competitive advantage for an organization only when they're connected and when the learnings and the feedback loops are in place. This should significantly improve the resource-based evaluation of the company. Typically this is calculated, the RBVs are calculated and measured and tracked for all their strategic initiatives, particularly on digital initiatives. And it will also help them identify the slack in the organization, as improvements are made. Often, we found that the subject matter experts or the process engineers or people who are directly connected to the solving of the problem are sitting in the fence and waiting while the data engineers work on preparing the data, providing the information they need. And it would be an iterative process which keeps happening. These SMEs or process engineers are, traditionally viewed as users or consumers of IoT and analytics solutions rather than innovators. This actually, what we've seen in our experience delays the benefits, and dilutes the return on investment, because a lot of energy in the organization is spent on this coordination and constant sharing of information between teams. Transitioning these SMEs, domain experts, process engineers into developers of analytic solutions and putting them right in the middle of innovation that they own and they're accountable for would be the key to success. So what we're trying to do here is to democratize the data analysis as well as analytics, so that all these engineers, whether it is SMEs, domain experts, data scientists, data analysts, can look at the organized data, experiment with what they would need to, learn from that, put their experience into action, define and solve problems. They can collaborate, innovate, and accelerate, and the time to value would be much faster with this process. If you're thinking that we are suggesting that data scientists or data engineers are not needed, that's not correct. Now that the process engineers are the center of the analytics solve, with the knowledge of the specificities of the operations, the processes, and the domain expertise that they have, which obviously the software engineers or the data scientists would not be aware about, they can drive what is needed from the software teams and data science teams to be more more specific and work around the problems that they can solve better. The data scientists and data engineers can again do what they do best in developing and testing new algorithms as the solutions get broader, rather than actually probably investing on the hard part of collecting, organizing, evaluating algorithms, listing insights and actions, identifying exceptions or opportunities for improvement, and most importantly, work on deploying and scaling this up. But these are not necessarily part of their skill set, and this should certainly be moved to the platform, and manufacturing analytics platform should be able to remove all these burden that otherwise plagues both the data scientists as well as the SMEs. So to summarize, this would be the typical flow of an analytics development cycle, and also could be the barriers to value, I'd say. The chosen analytics platform should have the ability to access data from both on-premise and cloud applications. The faster you traverse from steps 1 to 5, the quicker you would see the value, and greater you see the improvements in terms of efficiency. So we start by connecting the data sources together, capture the data, contextualize this, and prepare the data for analysis. Sometimes the information that you need may not be the information that you get from the data sources. The data preparation step should consider how to logically calculate the data that you need from the data you have. You would later move to the next step of using a sorted set of libraries of models. It could be statistical, ML, deep learning, to analyze the data, identify the root cause, and share operational insights. The box that you see here, represents what is called as a digital twin, which I'll talk about. So with this background that we have, we've come a little closer to defining what can be called as digital industrial, the intersection of the real and the digital worlds. What we would want is the real world of standard operating processes or the work process, physical systems, and processes to intersect with the data and analytics to create what we're calling as digital twins. So a digital twin is a set of properties that gets connected to a bunch of data sensors from various data sources and also from calculated values. These are combined to solve a specific analytics use case. So you can set up events on top of it. You can set up actions, alerts. This makes the twins more than just a replication of a physical process or an asset. This is what would turn out to be very unique for an organization where all the expertise, the experience, and the learnings of the organizations can be actually applied to create such twins. Digital twins are the fundamental units upon which analytics models are applied to gain operational insights. The best people to create such twins are obviously the process engineers or the SMEs. So with the fundamental units created, the digital twins created, you can actually go ahead with understanding or describing the problem, diagnosing the problem, predicting when the problem could occur, and prescribing solutions. So if you take a closer look, when a problem occurs, we would need the models to describe it and help us quickly get to the root cause. This is one of the most important activities that the platform should be able to do. We should be able to get the variables needed to analyze the problem and see if we can actually have some predictability there. Building such models, would be an iterative process, and here's where enterprise data would help. Where the learning could be not just in the narrow asset that we'd be looking at, but across related assets and processes. Simulating what-if scenarios on top of digital twins can establish and virtually create multiple scenarios, with which we can actually foresee what could occur before they actually occur. The final step in the analytics maturity would be to get a set of prescriptions or recommendations from the system on how the error can be avoided or its impact minimized. So if you take a look at the optimization and continuous improvement initiatives, considering that the digital strategy is aligned with business and that the specific areas of digital transformations are identified, the first step would be for the digital transformation teams to identify those champions, which we highly recommend the process engineers or the SMEs or the domain experts to be that. To work with these operators, the line supervisors or plant managers to understand the challenges that they're facing. At this stage, it's also important to define the economic value of the problem that they're solving. This is absolutely important because this is something that we have found to be one of the most crucial steps in our journey, when we are implementing analytics solutions. Time well spent here would actually enable more meaningful outcomes in the subsequent stages. The next step would be when the subject matter experts, the process engineers, domain experts sit together and contribute to the innovation. They're the ones who are directly connected to solving the problem, and they're the best people, as I mentioned, to create the twins, visualize the data, understand the hidden information within the data. As I say, in manufacturing, visualization is the first step towards problem solving. At this stage, it would be important to identify a pilot production site with a well-defined scope in order to solve, the problem that they're actually solving, trying to solve across the enterprise. The feedback on the analysis or the observations would then be passed to the operators and the supervisors to try and implement the recommendations. It would be necessary to create a closed-loop mechanism to set alerts or recommendations and forecast flowing to the operators and supervisors, and the overall improvement process or the efficiencies are captured. The teams can then look at adding more data, providing more information to the models, test multiple algorithms, and ensure that more accurate assessments of the models, of the algorithms, and the overall system efficiency would actually improve and would deliver as expected. Once this is established, then the pilot production would be termed as successful, and then you would have the ability to scale it up across multiple assets or multiple processes within the organization. This question often comes up, can I or should I run my analytics on cloud or edge or both? The answer is, it depends upon the problem that we're trying to solve. So if you look at the some of the scenarios where you might have to act quickly on the recommendation, for example, problems related to quality, center lining, or process-related problems where you need to actually respond quickly, detect quickly, problems related to critical failure of assets, or places where you don't feel comfortable actually moving the data out of the edge, you would actually more likely use analytics on edge. In all such cases, we would still recommend, the first option of having to learn on cloud and run on edge, meaning you do all the learning and the algorithm creation on cloud, or the relearnings can be done on cloud, and the analytics can be getting the executables, the runtime executables, which would be executed on the edge. The other approach, would be to actually learn and execute completely on edge. Again, this could be a scenario where, you would not want to move the data to cloud. Now, coming to the role of cloud option, cloud-based analytics, I think this is mostly preferred for operations and maintenance use cases. And also, this would be the preferred approach when you are looking at cross-learnings across the enterprise, or for scenarios where you need to deploy analytics at scale. Some of the most common use cases would include predicting quality. Examples include run CPK or first pass quality, predicting throughput or production. Examples could be predicting production rate, run length, cycle times, material cost per unit production, such things. Predicting energy efficiency could be one more use case where you predict energy cost per unit production. Predicting uptime, asset reliability, and asset life. These are some of the most common use cases that we have seen. Almost 90 to 95% of the use cases that we get fall in one of these 6 categories. So now this, in GE Digital, we recommend what is called as a hybrid cloud strategy, hybrid cloud data strategy, to be more specific, to get the best of both on-premise as well as cloud. On-premise because you have the lowest data latency possible, and on cloud because you get the elastic compute and storage on cloud. Again, scale, enterprise-wide, big data. In the larger digital transformation strategy, it is very important to identify the individual business cases and have a clear economic value associated with this. And here are some guidelines. So if you're looking at on-premise, you're looking at regulatory controls, you're looking at critical operations in terms of data latency, you're looking at the time of retention of the data and such factors. Whereas on cloud, you'll be looking at scale, cross-learnings, advanced analytics, non-critical in terms of data latency, the KPI reports like OE reports, OE predictions or sustainability metrics, those can be moved to cloud. Again, manufacturing execution tasks, which are not real-time, can always be moved to cloud. So optimizing this workflows to leverage both, the data that is retained on-premise as well as the one that's moved to cloud is something that needs to be handled as well. So let's look at a couple of use cases. I have picked up 2 use cases. The first use case is the one that was deployed on edge. The challenges were reactive maintenance on control loops, no visibility into developing loop problems, or diagnosing such problems were actually really cumbersome. The actions expected were to create a loop monitoring system that provides daily reports so that the staff can quickly identify an issue, minimize the deviation, and set the parameters. The results that we observed was optimized process and high plant availability, rapid and effective response to control issues, better decision making, and high standard of process control. The next use case which I would talk about is a use case that was deployed completely on cloud. The problem was The company wanted to reduce scrap from frequent line startups, formulation changes, and reduce the reliance on in-process testing. Because there was a gap of 30 to 60 minutes between the production and the time the quality was tested, the potential to generate scrap because of off-quality products were very high. The solution proposed was to implement predictive models for middle-of-line quality for finished product density, moisture, fat, and protein content. We monitored more than 75 process variables from across the production process to make accurate predictions for all of these 4 parameters in real time, plus provide recommendations to operators to keep quality on target. I specifically chose this use case because if you can see, this also talks about low latency, but the low latency is really not in milliseconds here. The payback period was less than 60 days. So let's summarize by looking at some of the key takeaways. The mantra at GE is not just to drive 2% or 5% or 10% savings post-implementation of analytics. Although we've seen 10x return on investments on most of our analytics solves, the expectation at GE is to generate savings year after year. So here are some of the pointers that could help create a sustainable and scalable AI-enabled digital transformation program. Again, this is something that can be tailor-made for your organization. So looking at, say, for example, if you start with, you would be actually looking at vendors or partners who would actually provide you with a full spectrum of analytics capabilities in simple on-premise as well as on-cloud products to simplify both your tactical as well as long-term journey. Start where you are and aim to rapidly implement incremental value, again, by empowering the resources that you have and using all the data and the infrastructure that's available. So this can be an approach rather than actually performing a big bang sequential approach. Again, we often get this question, the decision to do a rip and replace or start working on a Band-Aid solution approach. Again, we strongly recommend a bimodal strategy where you would actually start working on incremental fixes at the same time start looking at the larger vision of solving this problem across the enterprise and linking up with your overall digital strategy. Plan your journey, set your goals, and the most important thing is to clearly define economic value that gets added post-implementation. And you need to measure that so that the organization sees value and makes continuous improvements and investments. Define the scope. Again, as I mentioned, you need to actually pick up a limited scope, work on pilot productions, and then scale it up. You need to make sure that the solution is scalable. You need to evaluate the off-the-shelf capabilities or what can be solved quicker and faster by these products. And how can you get to the meat and potatoes of the analytics and quickly see some results? Again, the most important thing is to avoid what we call as the science experiments or pilot purgatories. These are the biggest traps that we've seen in analytics implementation. With this, I hope you enjoyed the session, and I will transition to Mark for the Q&A session.
Thank you very much. Now, Naran will answer questions from the audience. Please type your questions for the presenter in the Ask a Question box on the screen, and we'll get to as many questions as time allows. Questions that we do not get to today will be posted online with the archived version of the webcast. Remember to download a certificate of completion and a copy of the presentation by using the Event Resources tab on the left side of the screen. Okay, so the first question we have, what is the best way to prioritize digitalization efforts if I'm managing multiple plants?
So I think the prioritization should really come from the overall strategy that you would have in place. I mean, we strongly recommend to pick up low-hanging fruits. As recommended, choose, pilot sites, pilot areas, pilot lines, which actually can actually give you quick value and would actually give you, quantifiable economic value. I would suggest, go for that and then look at the results, gain some experience and expertise on implementing analytics and then scale it up.
Very good, thank you. Next question. We have several operations and IT systems which are siloed. Can you give some recommendations on how to overcome data set challenges?
Yeah, this is one of the most important questions that we often come across, because I think when you're choosing an analytics platform, it's very important for you to actually understand what are the connectors that the platform offers in terms of connecting to both legacy as well as modern data platforms, right? Again, when you're looking at cloud integration platforms, cloud integration solutions, where you're exchanging data, it's very important to see the data is homogeneous and well organized before you start exchanging the data. That's one of the reasons why we strongly recommend, using platforms that help you consolidate and homogenize the data and get to some common mechanisms of exchanging the data between those, information islands.
Good. Thank you for the chemical and pet food examples. What lessons learned there can be applied to other industries?
Well, I mean, as I mentioned, choosing wisely, what needs to be deployed on edge and what needs to be performed on cloud is very important. And that's one of the reasons why I picked up these two use cases. One was a classic example of, analyzing the data and looking at quality problems and, detecting patterns and, helping the line solve the quality issues. The other was actually going and fixing the control loop issue, which was more real time and, you need to respond in subsequent latencies. So these are two use cases. I think if you look at the lesson, or probably the reason why I put these two were primarily because in your overall strategy, you need to actually choose the best of both worlds. What we internally in GE call it as a hybrid data cloud strategy, which actually leverages the best of both on-premise as well as cloud deployments.
Very good. Please discuss again what should be local and what should be cloud-based in the architecture. We have some sensibilities about that here.
Well, actually, yeah, I think this is one of the questions that come up as well. Like if there is a hesitancy to move the data to cloud, for whatever reason, if the data that gets captured on-premise is large but very transient, for example, you don't want to capture it longer than probably a day, and you want to discard it, you would actually typically go for on-prem solutions, on-prem learning and on-prem execution as well. Whereas in some cases, you might prefer to actually move the learning part to cloud and actually execute the analytics on edge, meaning it learns everything that it has to learn from big data or from cross-learning across the enterprise and actually gets deployed on the edge so that it reacts to the changes faster. The other would be a complete cloud option where you learn and execute on cloud. So again, it depends upon the use case. So preferably what we would suggest is, any kind of process, optimizations can be done on edge. That means at least the executables should be running on edge. The learning can be happening certainly on edge. Operations and maintenance can be safely moved to cloud.
Good. Just a reminder to the audience, please type your questions in the Ask a Question box on the webcast console and then click Send, and we'll get to as many as possible. Here's another question. Thank you for the 6 common areas where advanced analytics are applied. How do we choose where to start and what should be next while we're prioritizing?
So as I mentioned, these 6 use cases, typically, in my experience, we've seen solves about 90 to 95% of the use cases that customers actually come with, the questions that they ask can be solved by these 6. So if something is falling beyond this, then probably, we can have a look at what's something out of the box that we can actually develop on top of the 6 that already exist. To answer your question, I think the quickest way is to identify the challenges that gets defined in one of these 6 areas, see the results, so that you can actually see the tangible benefits of analytics and prove to yourself that the analytics that you implemented works and works well economically for your organization, and then scale it up to probably a broader, analytics algorithms or working across multiple assets or processes or taking complex problems.
Very good, thank you. Yes, I like the idea of starting where we are, but we are in many places with data maturity. So I'd rather start where there's some consensus on data quality, where data doesn't have to be cleaned or reconciled or put into context first. Please comment about those issues.
Well, actually, I think one of the reasons why we always suggest the SMEs or the domain experts or the process engineers to be at the center of the analytics solve is for them to actually define what's needed, right? In terms of because they understand what data they're capturing and why they're not capturing. If they're not capturing, probably they can actually start capturing and look at ways of offsetting it with some other data, those kind of experimentations.
In your experience, is data in pretty good shape from most systems, or is there some cleansing that needs to be done?
We always find the need for cleansing, I would say, but I think the best people to clean this data would be the process engineers, because they know the gaps, they know the reasons why these are not captured, or they know the alternative methods where they can actually probably get, or they know ways to derive this information. For example, things like, for example, if they're capturing a specific sample rate and they want to actually capture data in between, probably they can actually create an algorithm to actually kind of capture the data in between rather than actually capturing and going and changing the process. But a typical data scientist or a software engineer would not understand what algorithms to apply there. I think that's where SME or a domain expert, would help significantly for addressing those issues.
And therefore, collaboration among them is very important when implementing, right?
Absolutely, yes.
Another question, when can we start seeing return on investment from implementing this type of solution?
As you saw in one of the examples that I've mentioned, it was 60 days. Within 60 days, they got the ROI. So, it can be as short as 60 days, and it can be, even a year. But what we've seen is typically the ROIs that they get would be 10 to 16 times their investment.
Very good. Please keep the questions coming. We'll get to as many as we can. Use the Ask a Question box on the webcast console and click Send. Please expand more about how to decide what to keep on the edge and what to keep on the cloud. Well, what are some good rules of thumb with that?
Well, as I mentioned, in my example earlier, so if you're actually creating a lot of data, a lot of raw data, but you don't really need it for your audit or regulatory compliance, or you don't want anything to be analyzed with such huge data. Probably you would have captured millions of samples, for when the process is being run. But you would like to actually only pass the summary information to cloud. In such cases, you would actually not keep the data, move the data to cloud. You would rather keep the data on premise and discard it whenever you need, and just pass the summary information back to the cloud. The other use cases could be, some sensitive information which you would not want to, for whatever reason, share it or move it to cloud, but you want to work on that at the edge level, you can do that. Or it could be, scenarios as I explained, where you need the lowest latency of, I'd say the response, from analytics, both in terms of capturing the changes and in terms of response. You could actually consider keeping some data for learning as well on premise.
Very good. In light of COVID-19 and the pandemic, what more can an organization be doing to optimize their plant and people and productivity?
Well, honestly, we have a lot of offerings on remote diagnosis and remote monitoring, and we see an increased demand for such offerings. This really means that the remote working or the remote assessment. I mean, people have started realizing that a lot of problems can be solved without having to be on the shop floor. Looking at the data, looking at what's happening, they can actually solve problems. I think this is what we have actually observed, particularly post-pandemic.
Very good. So it seems like this could help a lot, and many would embrace its use. How much justification and detail do you recommend as we build this proposal?
Well, as I said, I think it's very important. I think we strongly insist, even when we are actually talking to our customers, we strongly insist that pick up a business case where you see clear economic value. I think if the economic value is not visible, we would not recommend them to get that case, because for an organization to invest and they need to see value. I think the most important thing is to establish what are those baselines for measurement before we actually even start the analytics process. So that's our first recommendation, to pick up business cases which actually allows you to actually make a tangible measurement of the economic value that gets added.
Good. So next, among the 7 analytic journey recommendations at the end, which few require the most care or attention, and why?
I would say, avoid those experimentation and pilot projects, even if it's free of cost, because a lot of time is spent, and the real dilution of value of analytics happens because of these experimentation. I think what we need to do is pick up a clear case, well-defined case, and have it as a. I think this I would say as the topmost. I think the other would be to actually, see the capabilities of the platform. What kind of capabilities that it offers. How much of work it can offload from your most critical or important engineers, right, who are working on the solutions. I think this is the next important thing I would say.
Good, thank you. What is the most efficient route you would recommend to parse out the useful data from millions and millions of data points? I mean, some processes really do gather quite a bit.
Well, honestly, when you look at the cloud storage, it's very inexpensive these days. But I think if you're concerned about the bandwidth, the amount of data that gets passed from your on-prem to cloud, there are mechanisms where you can actually kind of compress and move the data. But again, if you don't need it, don't keep it, because I have often seen just because the compute and storage is elastic on cloud, organizations tend to move all the garbage that they've collected on premise to cloud. I think that identification is very, very important. If you don't need it, don't move it. But if you need something as summary, or if you can clearly set the retention policies for such data, make sure that the retention policies are set, then move to the cloud. That means You don't have to clean a particular place and make another place dirty. Just move the data from on-prem to cloud. That's not something that we would recommend. We would always advise to have a look at the data, look at the retention policies, and then see what can be moved to cloud.
And when you're doing that analysis, is there some retro nature to it? Can you see data that's happened in the past to use that for troubleshooting in the present or future?
Yes, right. Say, for example, we have observed customers, where they're actually sending the data, and the data really is not generating any patterns. The data is really not actually contributing to any sort of predictions that can be performed on the data. Right? You're just sending the data for the sake of capturing the data, where there's probably a very small variance, when you look at last 3 or 4 years data. We found in some cases up to 40% of the data that gets captured on-prem to be useless. That has never been used in the past, right? And probably it would not be used as well because the variance in the data is so small that, the information that gets, derived from that is very, very insignificant.
So someone gives you a call, Narayan, and says, help us out. So when you're working with the customer, what happens first? What's the process for implementing systems like these?
So what we do is, we work with them and make sure that whatever they define as the, as the data that needs to be ingested to cloud, we ingest them. We look at, we have algorithms. As mentioned in the introduction, I handle both data cloud, manufacturing data cloud, as well as analytics. So the preparatory step of preparing the data on cloud is something that we have well-defined mechanisms. We have models, as I said, we have templates that can be applied on top of manufacturing data. And we can figure out what are the missing links here. If there are certain things which are missing, or if there are certain, records where, probably you find 40 to 60% of the nulls, it's not captured because the process is not strictly followed. Or if it's captured in one side, if it's not captured in the other side, which is exactly producing the same part. Those kind of variations is what we would actually expose and give to the customers for them to actually kind of evaluate. And at this point is when the subject matter experts or the people who have configured those lines for production use would actually have a look at and see if they can fix those problems or fix the data. And then we actually apply those models and work forward. That's how the typical journey happens.
Very good. So when you're doing an implementation, are there certain things that you wish customers would more quickly understand when they're implementing the software?
Well, yeah, I think the first important thing, as I mentioned, is a clear business case, clear business case with economic value. I think the next step would be to see if there is adequate data, digitally captured data, for us to actually solve this problem. Because if the data is not captured, I think picking up such a use case is meaningless, right? So, these two should go hand in hand, I would say. One is to define, other is to make sure that the data is available. If the data is not available, at least, it's not too late. We can actually start capturing the data digitally, and, probably 2 months, 3 months, 6 months down the line, we can actually look at patterns and, help organizations solve the problem.
Very good. Time for one more question. Please give parting advice to people listening in.
Well, my advice or my recommendation would be, like if you are actually planning for digital transformation, it's actually a process. It's not an end state, right? So you need to actually constantly work on it. You need to actually kind of have it well-defined roadmap, well-defined milestones as to when you would achieve what. What I found, lacking in some of the organizations is this constant drive or constant, I'd say enthusiasm or, the willingness to actually participate in these initiatives, because the value is not generated faster. I think that challenge that we see is in terms of how fast, from the time the problem is given to the digital transformation team, how fast they come out with results, how fast they can actually go back to the users and say, okay, here it is, see what this can do for you. I think unless that happens, I think the journey would actually otherwise stop. This is what we've seen. So, and this enthusiasm, if it has to be maintained, and if the investments have to keep happening on transformation initiatives, then I think it's very, very important to speed up this process.
Well, thanks everybody for the great questions. And thanks again to our speaker, Naranga Gopalkrishna, for sharing his time and expertise. I'd also like to extend special thanks to our sponsor, GE Digital, for sponsoring today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. Finally, on behalf of Control Engineering and GE Digital, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.